Hello, welcome back. So we're gonna pick up where we left off with this combined gas law, and I'm gonna show you 4 demo problems on how to use this no matter what situation the problem asks for. So in your book, they're going to have these practice problems split up very specific for Boyle's law or Charles' law. This is common in all textbooks. However, I think it just complicates things too much for us. And so I think it's powerful for us to just focus in on this combined gas law, P1 V1 over T1 equals P2 V2 over T2, and use it for each of these situations. Okay, so let's look at our first demo problem. A helium balloon in a closed car occupies a volume of 2.32 liters at 40 degrees Celsius. If the car is parked on a hot day and the temperature rises to 75 degrees Celsius, what is the new volume of the balloon? Okay, so first thing I want you to do, I want you to write down your combined gas law. P1 V1 over T1 equals P2 V2 over T2. Okay. Next thing I want us to do is I want us to go in and highlight each of the numbers and see if we can identify what these are. So let's highlight this. I want it a little bit bigger. There we go. So our first one right here is a volume of 2.32 liters. Our next one is 40 degrees Celsius. And then our last number here is 75 degrees Celsius. All right, let's identify. Volume. If a helium balloon in a closed car occupies a volume at, so this is V1. It's our first volume. It's that initial property. At 40 degrees Celsius, that means this is our T1. If the car is parked on a hot day and the temperature rises, that means there's been a change in temperature. So this, therefore, is our T2. What is the new volume? Circle that. That's your V2 that you're going to find. Now you'll notice there's no pressure mentioned here. In these types of problems, if one of the variables is not mentioned at all, you can assume that it was held constant. That means it does not matter what number you choose to put in for that variable, as long as you keep it the same for both the first and the second of that same variable. So I'm going to suggest in that situation, choose 1. It's the easiest number to multiply and divide by. It doesn't matter, just choose 1. Sound good? So we know, therefore, our P1 equals our P2, and both of those are going to equal a 1. Now all we have to do is plug these values in for the right variable and use algebra to solve. What is our P1? Our P1 is 1. What is our V1? Our V1 is 2.32 liters divided by our T1, 40 degrees Celsius. Now, can we use 40 degrees Celsius? I hope you said no. I hope you remembered from the last video that in gas laws, the temperature must always be in Kelvin. So that means off here to the side, we've got to go 40 plus 273 equals 313. So that's what goes down here. Equals our P2. Well, our P2 again is 1. That's because the pressure is being held constant. What is our V2? Well, that's what we're trying to solve. So we're just going to put it as a variable right there. And then what is our T2? Our T2 is 75 degrees Celsius. Again, we have to add this to 273. And let me pull up my calculator, because I probably could do it in my head, but tonight I'm worrying that I'm going to get it wrong, and I don't want to be embarrassed forever. 348. Okay, So now we have this problem to solve. I personally think when you're dealing with ratios like this, proportions like this, the easiest way is to cross multiply them no matter which variable you're at. So that means we would have 313 V2 equals 2.32 times 348. We could divide both sides by 313, and we're going to get that V2 equals whatever this math equals. So I'm going to put into my calculator 2.32 times 348 divided by 313, and this is going to equal 2.58, when I put in for significant digits, 2.58 liters, because that's the unit for our volume. Okay, easy enough. Let's go on to number 2. A diver blows a 0.75 liter air bubble. I'm going to highlight that. 10 meters under the water. Now here's the thing, meters is distance. That has nothing to do with gas laws, so we're going to ignore it. It was extra information. As it rises, the pressure goes from 225 atmospheres to 103 atmospheres. What will be the volume of the bubble at the surface? That's what we're trying to find. So now let's identify which variables these are. 0.75 liters, that is our V1. Initially, he blows the bubble. As the bubble rises, right, because he's down under the water, it starts at 2.25 atmospheres. So this is our P1, and then it goes up to 1.03 atmospheres. This is our P2. All right, let's write down our combined gas law. P1 V1 over T1 equals P2 V2 over T2. Let's plug in. P1, 2.25 atmospheres. V1, 0.75 liters. What's our T1? Temperature isn't measured here, therefore we can assume it's constant, which means T1 equals T2, which means you can choose any temperature. I'm choosing a 1 because that's the easiest. 1 Kelvin equals our P2 is 1.03 atmospheres times our V2. That's what we're trying to find over T2 of a 1. Okay, so really when you look at this, anything divided by 1 is just itself. So really this gives us 2.25 times 0.75 equals 1.03 V2 divide by 1.03, and you find out, not V3, V2 equals, let's find out. Plug it into your calculator. 2.25 times 0.75 divided by 1.03. And you get that the new volume is 1.64 liters. Okay. Number 3. The pressure of the oxygen gas inside a canister is 5 atmospheres at 20 degrees Celsius. The canister is in a location where the temperature drops to a negative 10 degrees Celsius. What is the new pressure, right? So that's our P2 that we're trying to find. Let's go through and identify it. 5 atmospheres, that's our initial pressure. 20 degrees C, that's our initial temperature. The temperature then drops. There was the change, so our negative 10 is our T2, It doesn't mention anything about volume. Volume is constant, so V1 equals V2. And again, we're going to choose 1 because that's easy. There we go. Write down your combined gas law. P1 V1 over T1 equals P2 V2 over T2. Plug it in. Let's see, our P1 is 5 atmospheres. Our V1 is just a 1. Our T1 is 20 degrees Celsius. What do we have to do? Convert to Kelvin. So 20 plus 273 equals 293 for our T1. Our P2, that's what we're trying to find, times our V2 is a 1, and our T2 is a negative 10 degrees plus 273, which equals 263 for our P2. So now we have to solve for P2. Anything multiplied by 1, divided by 1, it just is itself, so we don't have to quite calculate that. We cross multiply and we get 5 times 263 equals 293 times P2. We can divide by 293 and we find out that our second pressure then is going to be 5 times 263 divided by 293, 4.49 atmospheres. Right? So the pressure went down because the temperature went down. That direct relationship that we talked about on the last video. I hope you guys are following along and things are going well. We've got one more example problem. Let's look at this. A gas at 110 kilopascals and 30 degrees Celsius fills a flexible container with an initial volume of 2 liters. If the temperature is raised to 80 degrees Celsius and the pressure is increased to 440 kilopascals, what is the new volume? So we're trying to solve for our V2. That's our question. Okay, what you notice in here is we've got a new unit for atmosphere, the kilopascals. You do not have to convert this to atmospheres. You can use it just as kilopascals as long as both your initial and your new pressure are the same units. So we're going to just work with kilopascals. So 110 kilopascals, that's our initial pressure. 30 degrees Celsius, that's our initial temperature. And it tells us initial volume. So 2 liters, that's our V1. If the temperature is raised, there's that change that signals that this is our T2 and the pressure is increased. So this is our P2. What is your new volume? So really mark up these questions. It helps you find it a lot easier. Notice we have all 3 variables referenced. That means nothing was kept constant. So we're using the combined gas law all the way through, just like we've been doing up to this point. Write it out. P1, not T1, V1. P1, V1 over T1 equals P2, V2 over T2. Plug in your pressures. P1, 110 kilopascals. V1, 2 liters. T1 is 30 degrees Celsius. We have to convert to Kelvin. 30 plus 273 equals 303 for our T1 equals P2, 440 kilopascals. V2 is what we're going to find. Our T2 is 80 degrees Celsius. We have to add it to 273. We get 353 for our T2. So notice we've raised our pressure, we've raised our temperature. Let's see what this does to our volume. Again, cross multiply. So this is going to take us to 303 times 440 times V2 equals 110 times 2 times 353. Okay. You can do your algebra any way you want in here. Some of my students try to multiply the things so that it gets simpler. I like to do it all in one step. So I'm going to head and divide both sides by 303 times 440. Because that's going to give me nothing but V2 over on this side. Now, when I plug this into my calculator, I'm going to multiply all the way across the numerator. 110 times 2 times 353. But then I'm going to divide by 303 and then divide by 440. You've got to make sure you divide, not multiply by 440. And you get that your volume goes down to 0.583 liters. It went from 2-liter volume to a little over half of a liter volume. Big change in your volume. And this is how pressure and temperature and volume all get intertwined and affect one another. And the combined gas law is the powerful way we get to calculate that. Sorry this video got a little long. I hope it made sense. Work on your homework, ask me questions, get confident with it. I hope you have a great day. I'll see you on Wednesday.